In this lesson we're going to look at ions. We're going to look at what ions are, and we're going to look at how and why atoms form ions. Okay, so at the moment we're looking at the electronic configurations of the atoms of the first three rows or the first three periods of the periodic table. And what we can say is that what these atoms want to do is they want to obtain a stable electronic or electron configuration. That's to say, they want to have their outer shells filled with the completed number of electrons. Remembering in the first period, the first shell has a capacity of 2 electrons, next period 8 electrons, and the third period, third shell, 8 electrons. Okay, so let's just make a note of that. Atoms form ions in order to obtain stable electron configurations to obtain a stable octet. So first of all, what we're going to do is we'll start off with group 8, that's to say the noble gases, also known as the inert gases, and you'll notice that in their cases they already have a stable electron configuration. They have a stable octet. Their outer shell is filled. So they do not need to gain or lose electrons in order to obtain the stable configuration because they already have it. Right? So group 8 will not form ions. They are completely unreactive. We'll say no ions formed here because they are stable. Now the other elements depicted here which will not tend to form ions are in group 4. It's carbon and silicon. Now the reason for that is that in order to form an ion, they've got to either lose their 4 outer electrons or they've got to gain 4 outer electrons. Now it turns out that it's quite difficult for them to do that. It requires quite a lot of energy to lose 4 electrons or gain or pick up 4 electrons, so they will not tend to form ions. So we can put no ions there in group 4, and what they will tend to do is they will tend to share their electrons rather than lose or gain. So in order to form an ion, the atom has to either lose electrons or it has to gain electrons in order to form the stable configuration. So let's just look at the atoms on the left. These are the group 1, 2 and 3 atoms. In order for them to form a stable configuration, in order for them to obtain their stable configuration, stable octet, they're going to lose electrons. We'll look at this more closely in a minute. And I would like to point out that I've only depicted the electrons in the outer shell here. What we're assuming here in all of these diagrams is that the inner shells are completed. They have the full number of electrons. So the group 1, 2 and 3 atoms here will lose electrons, while the groups 5, 6 and 7 will gain electrons in order to obtain the stable configuration. Okay, so let's just have a look at that a little bit more closely. So what we'll do is we'll look at the row 3 elements. So taking sodium as an example, in order to obtain that stable octet, it wants to get rid of this outer electron, so it's going to lose that. And let's write the ionization equation for this process. So we'll do that like this. We'll write sodium, and then we'll lose that electron, and because it's lost this electron, it then obtains a positive charge. Alright, so this will become a positive ion when that electron is lost. Magnesium, well, it's got 2 electrons it's got to get rid of in order to obtain the stable octet. So magnesium will lose 2 electrons, and so it will acquire a charge of 2+. And then aluminium, well, it's got a harder task. It's got to lose 3 electrons, and it will form an ion with a charge of 3+. Now going on to the non-metals, that's phosphorus, sulfur and chlorine, well, they're going to want to acquire electrons in order to complete this outer shell. So for example, chlorine's got 7 electrons, all it needs is an extra electron. It gains that extra electron, and so let's write out the ionization equation for this process. So this time the electron goes on the other side of the arrow because chlorine is gaining an electron and forms Cl-. So this ion will then have a negative charge. Now, and after that sulfur, well, sulfur has got 6 electrons in its outer shell, so it's going to want to acquire 2 electrons to obtain the octet. and so that's going to form an ion. Sorry, I forgot to put the minus sign by the chlorine, sorry about that. Okay, and the sulfur is going to acquire a 2 minus. And finally phosphorus, that's going to acquire 3 electrons in order to complete the octet. It's got 5 electrons at the moment, it needs another 3, and that forms the P3 minus ion. So where do we come across ions in chemistry? Well, we'll come across ions in ionic compounds, for example, and an example of an ionic compound is sodium chloride, NaCl, and when the ionic compound is formed, as we've just seen, the metal ion, in this case sodium, loses its electron to form a positive ion, and the chlorine atom will pick up that electron to form a chlorine ion. The positive and negative ions then assemble themselves into what is called an ionic lattice. We'll look at that more closely in the next unit when we look at chemical bonds, and these positive and negative ions are then held together by electrostatic forces. So that's where we're going to come across ions, and we'll also learn that, as you probably already know, that these ionic crystalline structures quite easily dissolve in water. Okay, so you know that salt readily dissolves in water, and when it does so, you know that the positive sodium ions and negative chlorine ions pass into the water and become free to move in between the water molecules. So because of that, these ions are able to conduct electricity, and so we'll come across ions in the area of electrolysis. So the ions can carry electricity between the electrodes.